Consider the region bounded by the curves y equals x cubed, y equals 0, and x equals 2. Find the volume of the solid obtained by rotating this region about x equals 3. We know that when we rotate a region bounded by a curve and the horizontal lines y equals c and y equals d about the y-axis, we use the formula the definite integral between c and d of a of y with respect to y, where a of y is the function that describes the cross-sectional area of the shape. So it might help to draw a little sketch. We have the curves y equals x cubed, y equals 0, and a vertical line at x equals 2. And so that gives us the region we're looking to rotate. This time though, we're not rotating about the y-axis itself, but about a line parallel to it. It's the line with the equation x equals 3. And so rotating at about this line, we'd end up with this shape shown. We call this a ring or a washer. And we can say that the cross-sectional area of the ring will be given by the area of the outer, the larger circle, minus the area of the inner circle. The area of a circle is pi times radius squared, and we're going to rewrite the equation for our curve as x in terms of y, so that's x equals the cube root of y. And we can say that the radius of the large circle would be the difference between the value of the function x equals the cube root of y and the function x equals 3. And so that's pi times the cube root of y minus 3 all squared. Similarly, the radius of our smaller circle will be the difference between 3 and 2. And so the cross-sectional area, or the function for the cross-sectional area, is pi times the cube root of y minus 3 squared minus pi times 3 minus 2 squared. We write the cube root of y as y to the power of 1/3, and we simplify 3 minus 2 to be equal to 1. The limits of our definite integral are found by considering the equations of the horizontal lines that bound our region. We know the lower of these is y is equal to 0. The upper limit is the point of intersection between the curve y equals x cubed and x equals 2, so that's 8. We take out a constant factor of pi, and then we distribute our parentheses. We end up with an integrand of y to the power of 2/3 minus 6y to the power of 1/3 plus 9 minus 1. And of course, 9 minus 1 is simply 8. We then integrate by raising the exponent of each term by 1 and then dividing by that new value. So we get pi times 3/5 of y to the power of 5 over 3 minus 18 over 4 times y to the power of 4 over 3 plus 8y. We then substitute our limits y equals 0 and y equals 8 in. Finally, we simplify, and we find that the volume of the solid obtained by rotating our region about the line x equals 3 is 56 pi over 5 cubic units.